Hello guys, today I want to cover the first problem from IB Chemistry HL paper 2. It was a November session last year, so let's get started. The first question asks us about the percentage by mass of nitrogen. So we have two nitrogen atoms and the whole mass would be as oxygen, and this is hydrogen, and this is gonna give us 35%. Next question. Ammonium ion is a Bronsted-Lowry acid or base, so it can, as we can see, it can only donate a proton like this. So it should be an acid. So we need to calculate the pH. As we know, pH is the logarithm of concentration of protons. So it basically means this, and this is 4.97. Ammonium nitrate is neutralized. So ammonium nitrate is neutralized with sodium hydroxide. And this is going to give us ammonia and water. So for the next question, for beginning, let's just imagine that all of our ammonia was neutralized and yielded 100% of ammonia, right? So because they are reacting in 1-to-1 ratio, it means number of moles of ammonia is equal to number of moles of sodium hydroxide, and because their concentrations are equal, that means volume of sodium hydroxide is equal to volume of ammonia nitrate, and that means the total volume of the solution was 40 centimeters cube, and so it was diluted by 2 times, right? So concentration of ammonia was 0.1 mole per liter, right? But this is, imagine this is before ammonia ion reacted with sodium hydroxide, and all of ammonia ions reacted with sodium hydroxide, and if there was 0.1 mole per liter and there was 0.1 mole per liter, that means that there is also 0.1 ammonia. However, we have this equilibrium right now, and I will just write it in this way because it will be easier to understand. And actually, the constant of this process is just Kb, which is 1.8 times 10 to the negative 5. And what we can do is say that the initial concentration of ammonia was 0.1, and X of them are reacted with water and gave us X ammonia ions, and OH minus, right? And we can write the equilibrium constant like this. And by solving this equation, we will get 1.33 times 10 to the negative third power. And so we can calculate POH, and then it would just be the logarithm of concentration of OH minus ions. It would give us 2.88, and then pH would be just 14 minus POH, and it would be 11,12. This is it. So now we need to sketch the graph. So okay, we titrated all of ammonia nitrate when the volume was 20 milliliters and the pH was about 11. So it would be somewhere here, equilibrium point. And we can just draw it basically like any normal titration curve. And this straight, of course, but it's kinda going up. Of course, it's much slow, but okay, it's just an idea how to draw it, right? So for the next question, I wrote for myself the range of Bromtimo blue. So as we can see, the range of it is 6.0 and 7.6, which is much smaller than our pH at the equilibrium point, right? So we cannot titrate ammonia nitrate with Bromtimo blue. The next question, we can just use this formula, right? C is 4.18, mass is 25.32, and here is just 25.2 minus 0.8, and it's gonna give us 2500 joules. Now we need to calculate the mass of ammonium nitrate that we need to dissolve. And if we dissolve 1 mole of ammonium nitrate, we would get 25.7 kilojoules, and so the mass would be, so the number of moles that we need to dissolve is just ratio of total energy that we need and total energy that we get from 1 mole, and it's going to be around 0.1 mole. And then mass of ammonium nitrate is just 0.1 times 80 equals 8 grams. And absolute uncertainty, right? And we need to, for this question, we need to calculate the absolute uncertainty, the mass of ammonia. Okay, first of all, we have like 25 grams, and this error is like almost negligible in comparison for in this one, right? Because we have 25 degrees, around 25 degrees, I think. And because we have two measurements of temperature before and after, it's going to increase our error twice. So it would be 0.4 and divided by the delta of the temperature that it changed. 24.4 and it's around 2%. So then the error of the mass is also around 2%, and the error in grams would be 2% by 8 grams, it's 0.16 grams. And now we need to again calculate the error. So error would be equal to the module of theoretical minus practical result divided by theoretical, and this is 15.7%. Calculate the standard entropy change. So the reaction, what is happening is solid dissolves in water, and the total entropy change is just entropy of aqua form minus entropy of solid form, and it would be 108.7 joules mole per Kelvin. And calculate the standard Gibbs free energy. So the formula for Gibbs free energy is delta H minus T delta S, right? Delta H for this process 25.7 from the booklet, minus the temperature is 298 and the enthalpy is 108.7 divided by 1000 because entropy is in joules and we need to answer in kilojoules, and this is going to give us minus 6.7 kilojoules, and we need to calculate the constant. We also know that Gibbs free energy is minus RT natural log of the constant. So the constant would be e to the power minus delta H divided by RT, which is going to be e to the power 6700, because for the constant it must be in joules, and I calculated this in kilojoules. This is 8314 and this is 298, and this would be 1494. All right. So because our constant is bigger than 1, then our equilibrium is shifted to the right side. So the concentration of dissolved ammonium nitrate is bigger than the concentration of the solid ammonium nitrate. For this part, we need to predict reactions that happen on the anode and cathode. So for anode, basically we have only one reaction, really, and this one, because we don't have NO and we don't have hydrogen gas in our initial solution, so it can't happen. And it would look like this. And on the cathode, we know that nitrate ion during electrolysis can't form NO. So for the second reaction is just the last one. There we need to write the following equation. Dinitrogen monoxide is basically dinitrogen monoxide. By the way, there was a fun story about dihydrogen monoxide, which is water, and some students, I believe, were pranking about dihydrogen monoxide, that it was dangerous, and I guess you can read this on the internet. It was really an interesting story. And now we need to calculate the volume of dinitrogen monoxide. What we can do is calculate the number of moles of ammonia nitrate is basically 5 divided by 80, and it's 0.0625. And because we from one ammonia nitrate we will get one dinitrogen monoxide, then number of moles of dinitrogen monoxide is also 0.0625, and we need to remember that ASTP is 273 kelvins or 0 Celsius, and at ASTP we can just convert number of moles to volume by simply dividing this by 22.4, and we will get 278 times 10 to the negative third power, and it's in liters. For the next question, we need to calculate standard enthalpy change. Again, I want to write this reaction. Can be not useful, right? And delta H of this reaction is just 2 enthalpies of water plus 1 enthalpy of dihydrogen monoxide and minus 1 enthalpy of ammonia nitrate. For water, we need to look at liquid. So it's minus 285.8. And we just need to simply calculate 2 times minus 285.8 plus 82 minus 366. It's going to give us minus 124. Predict sign of entropy and sign of Gibbs free energy. So we can see that, okay, this is nitrogen monoxide is a gas and ammonium nitrate is not. So because on the right hand side we have one volume of gas and on the left hand side we have 0, the entropy change would be greater than 0 because number of gases on right hand side greater number of gases on the left hand side. And for Gibbs free energy, again it's delta H minus T delta S. This thing is gonna be positive, but it goes with minus, so it's negative, and delta H is already negative, so we will be subtracting something from negative, and it's going to be always negative. So H is always less than 0. And we need to deduce formula for dinitrogen monoxide. It has 2 formulas, right? This is the first one, and This is the second one. Don't forget our charges. And also here. And we need to show electron dots. Like this. And they are both linear because it's SP configuration for the center of nitrogen, right? In both cases. So it's gonna be linear. I hope you enjoyed this problem. Let me know your thoughts about it in the comments. Thanks for watching and see you next time.